Are they what?
Are they the easy ones we learned to be making?
Well, logarithms are still logarithms. Something that is important is condensing and expanding logarithms. Okay, so I'm hoping that you may not need to write these down, but if you want to, you can. Remember, if we're multiplying inside of a logarithm, we can break it apart, two logarithms being added. If we're dividing inside of a logarithm, we're breaking apart with subtraction. Logarithm to a power. The power comes out in front. Well, this is just writing it as c to the negative first. It's really not necessary, I guess, because it's just kind of this one up here. But just remember that you can rewrite those as exponents. Okay, so we will need to be able to expand logarithms to help us with some of these derivatives. Okay, do you enjoy the quotient rule?
No.
Some of you think it's a pain in the butt. If there is a quotient inside of a logarithm, we can expand a logarithm and avoid the quotient rule. Okay, so this is actually going to be helpful. All right, so let's just practice doing some expanding. I'll give you a sec, but only one.
Wait, so for the last one, like all three of those are the same thing?
Okay, so let's look at this one. Log base 5 of this mess. First of all, square root means what? 1/2 power, right? So when we expand this, it expands to what?
1/2 log x of quantity x plus 1 minus log, 5, that's 5 of x.
Okay, so the 1/2 is in front of your logarithm for the x plus 1, and then we're going to subtract log of x. Because we're dividing, we're subtracting the two logarithms. Do it again. We cannot break apart addition inside of the logarithm. We can only break apart multiplication and division. Okay, so this is as expanded as it can go. Okay, but this will be nice when we are taking derivatives. If we can expand it, that will be helpful. All right. What about this one? Okay, so first of all, let's do one thing at a time. These two are being multiplied, so we can make two logarithms that are being. Okay, so natural log of x plus 3 cubed plus natural log of x plus 1. And then divided means minus natural log of x plus 10 to the 1/3 power. Is that okay?
Could you move the exponents to the...
Yep. And then we would move the exponents to the outside of the ones that is.
Would you put parentheses around the first one? Since that's cubed divided by 1/1.
It is not necessary, but you can. Since multiplication and division are tied, addition and subtraction are also tied, left to right is the order in which we would do the operations. And so left to right, this would still be equivalent. If you put parentheses, it's not going to be wrong.
It's a parentheses, not for our whole organization.
Now, if there were two things in the denominator, then that would need parentheses. Okay. All right, so let's talk about the derivative of the natural log. The derivative of natural log is 1 over x. Remember it.
You don't want one.
Well, do you want to do the limit of the difference quotient to find out? F of x plus h minus
Oh,
7.
that's it, yeah.
Okay. I don't know if we're gonna have time right now. Okay, we have a lot to get through. We want to I want to focus on examples. But that is how we would have to do it. Okay. All right. So what about if I have the derivative of the natural log of f of x? Okay. So what's the derivative of natural log? 1 over what's inside
Remember after that.
times
The derivative.
the derivative of what's inside. Yeah. I got a little staff line. Okay. So, shall we? Okay. So the derivative of natural log is 1 over x. If something's inside of our natural logarithm, 1 over that times the derivative of what's inside. Chain rule, right?
Or can you just do the derivative of the inside divided by the original?
Yes. Yes, you can. Because we use the chain rule to write this. Okay? All right. So first of all, let's find the derivative of the natural log of 2x. Okay? So derivative of the natural log, 1 over whatever,
2 over x.
times derivative of the inside. So our derivative is 1 over x.
Yeah, this wouldn't be bad.
Okay, what about this derivative? Derivative of the natural log. 1 over whatever times derivative of what's inside. So we have 2x over x squared plus 1. You're ready for what?
I'm waiting for it just to get farther.
Yeah.
I'm waiting for the E
Yeah.
of numbers.
Waiting for it to
Oh, I'm waiting for.
You get that's just a log of the next.
Second derivative.
This is just a log of e. Hold on.
Yeah, we've done.
Natural log is just.
Can you move it up a little bit?
Of course. Do you have a question?
No.
Natural
Why
log
is
is
it?
Okay, so when does it get complicated?
Now I know the normal logs.
Not yet, just kidding. I forgot I had these examples. Okay. X times natural log of x. Oh, dang it, I gave it away. What do we have? We have a product. So, the derivative of the first times the second plus the first times the derivative of the second. And so our derivative is the natural log of x plus 1. You say what? I like the natural log of x as a derivative. It's nice. We'll get there. Okay, so how about y equals the natural log of x cubed? We are going to have to do the chain rule. So our first derivative we need to take is
Outside.
power rule. Drop the 3. The power is now 2 times the derivative of what's inside. Okay, so we can write this as 3 natural log of x squared All right. Now, if I gave you this, do we want to do chain? We can expand and just do two separate logarithms, two separate derivatives, right? So, how would we expand this? Okay, so first of all, 1/3 times natural log of the numerator minus natural log of the denominator. Okay, since all of that is in the radical, I put the 1/3 times all of it. Do you agree with that? Okay, so now when we take the derivative, okay, the constant is going to still be multiplied to the derivative. What's the derivative of natural log of x minus 1? 1 over x minus 1. Minus, what is the derivative of the natural log of x plus 1? 1 over x plus 1. What?
Wait,
I do it like this.
could you distribute the 1/3?
You could, and so you could see it like this.
I can't, because you don't have to use the chain rule because you brought the 1/3 out, right? So
Well-
the regular y has 1/3 on the other side times that quantity. So in other words, you either have to use the product rule or
Well,
you have to.
remember we have that rule of a constant times a function. Our derivative is going to be a constant times the derivative times the derivative. A constant times any function. Our derivative is going to be the constant times the derivative. Okay. Yes, I know what you were saying, but okay, let's think of like when we do the product rule. If we have y equals 2x cubed, the derivative is 2 times 3x squared. Right?
Yeah.
Okay? Same thing there with the 1/3. We have 1/3 times all of that. So our derivative is 1/3 times the derivative.
You got it.
What was that say?
This one? That's still the x minus 1.
On the white one, that'd be a 6.
It would be 6.
Yeah. So all I did was I put the 1/3 through. Okay.
Yeah.
If you kept the 1/3 in front of each of them, you'd still get to the same place. Okay. All right. So I want to talk about this. Sometimes you may see absolute values inside of our logarithms. Why?
Because you can't have a negative log.
Okay, we can't have negatives inside of the logarithm. Okay, that's not okay. So, what would, like, for example, cosine of x. Can cosine of x be negative? Okay, because it oscillates between 1 and -1. So, we can't just put the cosine inside of the natural log. Instead, we have to put it as an absolute value. Now, that is not going to affect our derivative, though. Okay, so what would the derivative of this be? First of all, what's the derivative of natural log? 1 over what's inside times what's the derivative of the inside? Negative sine x. So you would tell me that the derivative is negative tangent x. Well, the first one,
So the actual amount just makes it permanently.
right,
The person kind of reading it, the part of the stories, the person reading their option, the person who's not doing
right. So, it wouldn't be differential then. Okay. Natural log of the sine of x. We have the absolute value because it can't be negative. Okay. However, we take the derivative of this. Okay. So we have 1 over what's inside of the logarithm times cosine. So like Aaron said, cotangent of x. Now, okay. In this one, okay, I don't have the absolute value. Is that okay? Okay. This is a parabola where I believe it's all above the x-axis. Okay. How do we take the derivative? 1 over what's inside times 6x plus 5. All right, so someone asked earlier, what if, yes,
I don't understand why in this one we did like the roller cosine times minus sine of x, and then in the one before, the last slide, we do multiply.
here?
Yeah.
Okay, well, what's the derivative of what's inside? 1.
Oh.
So we kind of did, but I did it right. Okay. So what happens if our base is not 10? Or if it's not base E?
Then we get spooked.
What?
We get spooked.
Okay. So what I want you to think about is, don't write this down yet, but the change of base formula. Okay? Right. And so let's take the derivative of this to get our rule. Okay? Just don't write it down. Don't write it down. Just bear with me. Okay? What's the derivative of this? So this is a quotient, right?
Okay, we converted it to natural law, it's not straight law.
Right. Change of base formula, you can use whatever.
Oh.
Okay? So so we have low D high minus high D low. Is A a variable?
I don't know.
A is a constant. What's the derivative of constant?
0.
So we have 1 over x times the natural log of A over the natural log of A squared. Right? Which means those cancel.
So it's 1 over
So 1 over x times the natural log of A. Yes. So, let's talk about what that means. Where's my extended page? Excellent. Okay. I don't know. So this is our derivative. This is your rule. So, it looks pretty similar, right?
Sure.
You have the 1 over x, but if the base isn't e, you need to multiply by the natural log of the base in your denominator. That's the only difference. Yes. The natural log of a, since a is a number, it's a constant, so it's just a number. The derivative of a constant is 0. Okay? This is just me proving what this derivative is. Okay? So what I need you to do is remember how to take this derivative. Okay? Yes, this is what you need.
So pretty much like if we get something that's log base A like x, then we just plug it into that.
Right,
Question.
yes.
At the same time, could that be 1 over x natural log of a? X times natural log of a, therefore, to be the natural log of a to the x power.
I mean, I guess technically yes, but we're not gonna write it like that because not very often are we gonna get just x inside of the logarithm. I want it to look like this, either this way or this way. Okay, don't make the exponent. Okay. Okay. Would you like to see some examples?
Yes.
Examples always help. Log base 3 of x. So it's a logarithm, not base e. So we still do the 1 over x, but then we also need natural log 3. That's it. That's it. So it's still the 1 over x. We just have one more thing to put in there. Log base 3 of 3x. Okay, what's inside the logarithm? 3x. So we have 1 over 3x. And since it's not base e, we have to multiply by the natural log of the base. Times chain rule. Derivative of the inside is 3. Three over 3x.
Because inside of the log,
Carter, what's your question?
I was wondering where you got the 3.
Which 3? This one?
No, the other.
This one? This
Yeah.
one. Okay, since inside we have 3x, we have to do the chain rule. Is that good? If there's not a base, what is it?
I know this.
It's base 10. So, derivative, 1 over what's inside. It's not base e, so we multiply it by natural log of 10. Chain rule, what's the derivative of the inside? Negative sine of x. If you write it as negative sine of x over cosine of x times natural log of 10, I would accept that. How else could you write it? Negative tangent over natural log of 10 would also be fine. You know, there's going to be some simple ones. There's going to be some not as simple ones. And there's going to be some that we'll need to expand before we can take the derivative of. Okay? So let's take the derivative of this one. What's our base on this logarithm? 10. So when we take the derivative, 1 over what's inside times natural log of 10 times derivative of the inside. We have to do the chain rule. Okay? So I have 2x over x squared plus 1 times the natural log of 10. Can I simplify that 2 and 10? Absolutely not. Okay? That 10 is inside of the logarithm. It's inside of a function. It is not a coefficient of any kind. Okay? Now I think I'm gonna skip over this example and come back to it if we have time. But let's just talk about how would we do it. We would have to expand it first and then take two separate derivatives. Okay. Now, I want to just see if we have time because we need to talk about something a little bit important. Okay. Why take all of these logarithmic differentiation derivatives? Okay. Yes, we're going to have some equations that are logarithmic. Okay. But it also can help us with some derivatives that aren't logarithmic. What do you mean? Look at this equation right here. And I want you to just think about taking the derivative of this with the quotient rule. How tedious would that be? Okay? You would have to do the quotient rule, and there's going to be chain rule in there multiple times within the quotient rule. Okay, right? So, like, your stomach hurts just a little bit thinking about it? Maybe, maybe not?
True.
Okay, so what we can do when it looks pretty messy is it legal for me to take the natural log of both sides? I'm doing the same thing to both sides, right? Okay, why would that be helpful? Now we can expand that right side. So we have the natural log of y equals 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Okay. Now the derivative doesn't seem so scary, does it? Oh, we haven't taken the derivative yet. We just took the natural log to both sides and expanded it. So now we're going to have to take the derivative. Zach's making that noise because what kind of an equation do we have right now? Implicit. So we have to take the derivative. It's okay. Natural log of y. What is it? 1 over y dy dx. Okay. Now we have 2 times derivative of the natural log of x minus 1. 1 over x minus 2. I said the wrong number. I apologize. Okay. Times derivative of the inside is 1. Okay, so we're not going to write it. Minus 1/2 times derivative of natural log of x squared plus 1. Times chain rule. Right? So I'm going to make this look a little bit prettier. So we have 1 over y dy dx. I'm going to write this as 2 over x minus 2 minus x over x squared plus 1. Right?
The 1/2 that one's 5
Okay.
All times.
Now, all times y. So dy dx equals y times 2 over x minus 2 minus x over x squared plus 1. Now I have a question. Okay, so what did I do? We just multiplied the y over to get dy dx by itself. Did this begin as an implicit function? It started out as explicit, which means your derivative better be explicit. All right? An implicit derivative can have x's and y's. An explicit derivative, no. So what can we do? Do we know what y is? Oh my gosh, I'm rewriting it. Y is x minus 2 squared over the square root of x squared plus 1 times 2 over x minus 2.
Second derivative.
Nothing, the second derivative.
So we don't have to simplify there, we're fine?
You can leave it like that.
Let's on the second
We weren't
Okay.
trying, we weren't
Now-
trying with the rewrite, we were trying with the simplifying after the rewrite.
Oh, okay. No, we can leave it like this. Okay? Right now, yeah, we can leave it like this. Okay, now I want you to just think about how the derivative would have gone with the quotient rule.
I'm still working on
We would still be working on it, wouldn't we?
it. Just have one question. Why is it not allowed to be implicit?
Because we started off with an explicit function,
So,
so I want the derivative to also be explicit.
how is that important?
Um,
Like, what rules are behind that? How will this affect us? Will that affect us?
will it affect you later? I'm trying to think.
Implicit, and was it an implicit function?
What?
Was it an implicit function that was an implicit function? Or a derivative?
Derivative? I just want you to think about like if we have a function that's defined implicitly, it's okay to have y's in the derivatives. But if our function is defined explicitly, I want it to be in terms of x. I suppose if I asked you to find the second derivative, okay. Right now, I'm not going to, okay. But it's easier to take the second derivative explicitly, isn't it? Debatable?
That's debatable.
I just like how it is now, I don't want questions.
Okay. If it starts out explicitly, I want the derivative to be explicit as well. Okay. So I don't know if announcements are coming on or not. We didn't have announcements at the beginning like we usually do, did we? No. Okay. So what I'm going to do is I'm going to give you your homework, and then I'd like to go through our blue sheets.
We're not gonna,
Is the
What?
we're not gonna go down to.
Um,
It's just not, we all know how to expand mock codes.
okay? Oh, that was a little sassy there, is that?
I actually would like to go over the blue sheets because there's some important things that I want to talk about, and I want to save time tomorrow to talk about these half sheets that you just turned in.
Is the page 362 the problem?